Welcome to CS288W Network Administration. We're now in Module 2. We'll be covering Chapter 3, Networking with Windows Server 2008. So let's start by talking about our objectives. We're going to identify the basic components of a network, describe the features of IP version 4 and IP version 6, which you'll be doing some of that in your labs as well, configure clients 4 and 6, upgrade a network from 4 to 6, and troubleshoot TCP/IP. Basics of networking. A network is a group of two or more nodes. So anytime you have more than one computer or computing device that is networkable, then you have a network. That could be two PCs, that could be a PC and a network-enabled phone or tablet, or two tablets, whatever you want to do where it gets an IP address. If you have more than one of them, then you have a network. Networking is the practice of designing, implementing, and managing a collection of computers and devices on a network. Types of networks: network scale, connection methodology, network architecture, the topology, and the protocol. And we're going to talk about that here shortly. How networks occupy geographic space. Most common types of networks: LANs and WANs. LANs is generally anywhere inside your office or your home, and a WAN is as soon as you leave that LAN, you go out to the rest of the world. There are also MANs, which we won't cover in this particular course, but it's for metropolitan area networks. If you have a citywide company with many different branches, and there's some other ones as well. Connection methodology defines the type of hardware technology used for connecting network nodes. So we're going to be talking about the methodology of TCP/IP. Topology categorizes networks based on the physical and logical relationship among devices. There are multiple different ways you can connect computers to each other, and two of the ways that are fairly common are the star and mesh networks. A star network would be where you have a hub or switch where all the other computers and switches and routers and firewalls all plug into. A mesh network would be where every device is connected to every other device. Of course, that can get very expensive, so it's not as well used as the star method. There's also the ring method, which is used for older technologies that we tend not to use today, because if that ring is broken, then it's broken for everybody. So the star is definitely the most popular and cost-effective way of connecting your networks, where they're all connected to one or two main switches. Network protocols, they allow network nodes to communicate with each other. A protocol is just another word for language. So what network language is your computer communicating on? The most popular, of course, is TCP/IP, but there are other protocols that have been used in times past, such as Banyan Vines, there's IPX, SPX, and NetBEUI, and others. Network interface cards. These are the hardware cards installed in computers so that they can connect to a physical network. And this could be a wired interface card or a wireless card. It doesn't matter as long as it can get an IP address on it. It is a NIC. A repeater or a switch is a hardware device that receives a signal and then resends it at a higher level or power. So a switch is one of the more common types of repeaters, but a repeater could be just one port. Since most TCP/IP or Ethernet networks can't go more than 300 feet if you're using standard Cat5 cables, you would need a repeater in order to boost the signal if you want to make it go longer than that 300 feet. So a repeater can be just a single port, or it can be multiple ports like a switch. Hubs, they have multiple ports to which nodes are connected. Hubs are not devices that we use so much anymore because they don't have any memory in them. A switch actually has some memory, which we'll talk about in a second. A hub tends to broadcast a lot of the traffic, so it makes the network run slower, but up until about 10 years ago, that was the most popular way of communicating. Bandwidth describes the amount of data that can travel from one network point to another within a specified time. So you probably purchased a certain amount of bandwidth when you bought your internet provider service for your home or business. And they said, this is your download speed, this is your upload speed. That is bandwidth. And you can have that bandwidth go up or down based on the technology and what the internet provider sells to the public. Network bridges, it connects one or more network segment. These are things that, again, are not used as much, similar to hubs. They're not used as much as they were at one time, because switches can do both the job of a bridge and a hub, and it can do it more efficiently. So if you wanted to connect a one network segment with another, and then you can do that with a bridge. I know that was very popular up until about 10, 12 years ago, when switches would do the job more efficiently. So switches work at the layer 2 of the OSI model and forward frames between ports based on MAC addresses. So this is what makes the switches so much better than hubs and bridges, is because they use that information based on MAC addresses. The MAC address is the hardware address that's built into every single network interface card. In most cases, you cannot change that MAC address, and therefore the MAC address has to be unique. You cannot have two network cards with the same MAC address on the network, otherwise the switch will get very confused and start to cause a broadcast storm. So what makes switches unique besides the MAC address is that it also has a memory. And the memory says if you are connected into one port, it memorizes your hardware address, your MAC address, as well as your TCP/IP address. And so when someone else wants to communicate with your computer or server, then the switch remembers where it was, whereas bridges and hubs would just broadcast that information. It would say, where's the server? You'd find the server, send the data back. The next time somebody says, where's the server? Then it broadcasts it again. Switches don't do that. Switches remember where it is, so it doesn't require all that broadcast information and makes the network far more efficient. A router is responsible for forwarding packets between subnets or networks with differing IP addressing schemes, using dynamic routing protocols and pre-configured static routes to deliver packets, and always connected to at least two networks. So what this basically means is the easiest thing to picture here is the inside of your network and then the rest of the world. So what connects you to the rest of the world on the internet is a router. So in some companies, they have routers within their offices to segment different departments or different locations, such as I did work for a TV station, and they required routers in their network because they had a MPLS connection to other TV stations in other cities. And they would forward data back and forth between those different TV stations. So we would have routers connecting all the TV stations together. In one network, it might be 10.1.0.0. In another network, it might be 10.2.0.0. So they have to be on different subnets in order for a router to route those packets between them. Whereas a bridge or a switch can only send data if they're on the same network, such as you have to be on 10.1.0.0 on one side and 10.1.0.0 on the other side. So that's the same network. Routers only do it on differing networks. IP version 4, the industry standard for network addressing. So we are running out of IP4 addresses, and I'll tell you why shortly. But this is the one that we are still mostly using, although we are transitioning over to IP version 6, which we will talk about in length shortly as well. TCP, Transmission Control Protocol. This sits on top of IP, so that's why it's TCP/IP or TCP over IP. It is a set of rules to exchange messages with each other or with other internet points at the information packet level. It guarantees the delivery of packets. So TCP definitely takes advantage of making sure that a packet actually gets delivered to the other end using a handshake. So once that handshake is created, a state connection is made, and once the data is delivered, the other end of that handshake will send a message back saying the data has been delivered, and you now know that your data has been safely made available to the other party. UDP over IP is different. It is stateless. And UDP tends to be used where communication does not require acknowledgement that the data has made it to the other side. UDP is much faster than TCP because it doesn't require that acknowledgement. We also call it an ACK. And the typical use for UDP would be in games. If you're on a network server playing against other people, on a large multiplayer game, then you're probably using a lot of UDP packets. IP version 4, based on an addressing scheme that uses unique 32-bit or 4-byte addresses. So 2 to the 32nd power is only going to be 4 billion addresses. We have run out of those addresses. We're already starting to use version 6. You can continue using version 4 on the inside of your network for as long as you want, because you'll probably not go more than 4 billion addresses in your home or business. But on the outside, we are quickly moving to version 6. Subnet mask can determine the network and host portion of an IP address. So to show you an example here, if we decided to take a 10.1.1.0, and then our subnet mask was 255.255.255.0, and let's go ahead and split up this a little bit to give you an idea, where we put the numbers directly over the subnet mask. So the 10 is being masked. That means, so this is going to be the network side. The 1 is being masked, and this 1 is being masked. So this is all the network side. So in order for you to communicate with someone else, they also have to start with 10.1.1. Now, this last one you see is not being masked by a 255 number. It's got a 0 here. That means this is the host side. The host is your PC itself. So your PC could be .1. The next PC has to be also on the 10.1.1, but it can't end in 1. Now you have to be on a different number for the last one. So it'll have to go with 2 or some other number all the way up to 254. So this is similar to, say, a street, and this is similar to a street address. If you're on Main Street, this would be similar to Main Street. You have a house number of 1. You can't have 2 house numbers on Main Street, both being 1, or the post office won't know how to deliver your email, or your mail, I should say, to anybody else's mail. So you have to be a 1, but somebody else has to be a 2, and then somebody else has to be a 3, etc. So this is the host side, this is the network side, and you can tell that by the mask. This is masking the network side. That makes this the host side. Now, if we changed this number to 255.255.00, now only the first 2 numbers are the network side, and the last 2 numbers are the host side. So this obviously gives you a lot more hosts. So I could make this 10.1.123.2, and it would be on the same subnet as my 10.1.1.1, because it only masks the first 2 part. So if you want to have a lot of hosts, then you have this sort of subnet mask. If you want to have just a little bit of hosts, like most homes and businesses have, then you'd have this subnet mask. Now, you can get much deeper into this, and there's other numbers we can do, but that just sort of gives you an overview of what the IP4 subnet mask can do. Public addresses, these are issued addresses that are available from the internet. So when you sign up for an internet service provider, they will give you either a dynamic address, which could change whenever is necessary, or a static address, which is always the same, such as used on websites. You don't want that website IP address to change all the time, or nobody can find you. They are centrally registered and maintained through ICANN. This is now an international organization that assigns both domains and IP addresses. In America, we use ARIN.net, A-R-I-N, American Registry of Information Numbers, but they all report back to the international ICANN location when the United States gave up central authority over the IP addressing for the world. Private IP addresses not available or routable on the internet and used by administrators for deploying internal networks. So when you have a private IP address, it cannot be routed out to a public address. So in other words, you cannot have a website that starts with 10.0.0.1. That's a private address. But you can have it be something else, such as 5.7.2.3. That could be a public address. So this gives you a list of all the different addresses that's called special use addresses that are non-routable. These addresses cannot be used outside of your own private internal network. They can be routed, however, to public addresses using a firewall that does what's called address translation, which we can talk about another time. So if you look at the 10 dot address, so anything that starts with a 10 is by default a private address. Anyone that starts with 172.16 through 172.31 is another block of private addresses, and 192.168.0 is private, and there's a IP version 6 to IP4 relay, which is used when you're trying to convert addresses from 6 to 4. So that's some of the different blocks of IP addresses that you know ahead of time cannot be used as public IP addresses. Let's talk about IP version 6, the future of IP on the network, on the internet, and on public and private networks. Mainly because we ran out of IP4 addresses, 2 to the 32nd power. Well, IP version 6 is 2 to the 128th power. And that is, if you break that down, it's 80 billion IP addresses for every man, woman, and child on planet Earth today. So we should have plenty of IP addresses using version 6 for quite a while. The address structure, because of the fact that IP version 6 has such a long string, it's 128 bits, then you need to have some way of shortening those addresses so they're easier to plug in instead of having to type out all those different characters. Now, IP version 6 is hexadecimal, which makes it even more complicated, and they're grouped into two numbers separated by colons. You can learn more on page 94 in our book. So, notation usage. If you recall from your previous classes, you used universal naming conventions in order to get to shares. So you would do a // from a run command, and you would put in the server name, and then you could see the share name. Well, if you use that same kind of logic with a version 6, you can see that if you use a UNC and decide to put in the IP address instead of just the name, the IP addresses are separated by replace colons with dashes. So you would use the minus key as a dash key, and that would allow you to see the UNC path to an IP address on version 6. In IP version 4, you would separate them with periods. So if you were to shorten a URL, this is like a website instead of a UNC, you could put in HTTPS just like you would for any secure website using secure sockets. And then you could put in brackets FF06, and you see the dots. That's because all these numbers inside them are zeros, so that's why there's just dots there. That way you don't have to type out the zeros all the time. And then again, brackets and colon, whatever port you're going to use. So this is a little bit complicated, I know, but it makes more sense as you go through the labs and go through the course itself. So there's different types of IP version 6, just like I showed you in that previous special use area. There are lots of different things such as special addresses in version 6. So there's link local addresses, and the link local addresses are private networks, just like using the TCP IP version 4 private network, such as the 10 dot, the 192.168, etc. There's unique local, which is the exact same thing as the link local, so just like the private IP addressing, except a unique local allows you to route to multiple different subnets inside a network. So you wouldn't see this necessarily in a home, but in a business, you might have several different internal subnets being used. And if you use IP version 6 in order to network those, you can use a unique local address scheme instead of a link local address, which just allows for one subnet. So this allows for multiple internal subnets. Global addresses are the same as any public address on an IP version 4. So global addresses are the ones assigned to you by your internet service provider. Multicast addresses are a little bit different. It allows you to send one address, your own host address, out to many addresses all at once. This is used a lot of times for things like video addresses. For instance, I was at a company many years ago where the president of the company was in Florida, and there was offices all over the world, and he wanted to send out a video address to everyone to talk about a merger that was happening. So when he did that, he used the network IT department used multicast to do that. So from his one single address, he was able to broadcast out not to just another single address, but to every single address all at once. It's a much more efficient way of communicating when you need to do so to multiple computers all at once. Special addresses are just like the special addresses in version 4. They allow for things like loopback addressing and mapping for converting to IP version 6 to IP4, things like that. So there's all different kinds, which I'll show you in the next slide here. And you can see the special addressing. 6 to 4 addressing, mapping IP version 4, loopback addressing. Loopback is used for troubleshooting a network address. If you're not sure if your TCP/IP is working properly, you ping the loopback address in either version 4 or version 6. And so Teredo addressing allows you to troubleshoot as well as connect to multiple version 4 and 6 addresses behind one router. All right, let's talk about some other things here. Configuring clients for version 4 and version 6. DHCP, we'll be setting up a DHCP server in one of the future modules, so you'll be able to see how automatic IP addressing from a server is set up. APIPA or APIPA is automatic private IP addressing. This happens in a computer when it does not see a DHCP server. So if there's no DHCP server in the network, it uses APIPA, which automatically assigns it a 169 address. So if you've ever opened up your IP addressing and seen a 169 address, it's because your computer cannot communicate with a DHCP server, so it just gave itself an automatic internal private address. And that allows multiple computers to connect to each other that way. Alternate configuration used to set static IP addresses in your IP configuration that will be used if DHCP is not available. So besides DHCP for automated or APIPA, in case it can't see a DHCP server, you can statically set your addresses. And we'll be doing that in this next lab. Manually configuring IP addresses, often referred to as static. It's another term, another way of static configuration, like we just talked about. Static IP addresses used where there is no DHCP service. Configuring clients for IP4 and IP6 continued. Almost all computers automatically configure IP version 6 settings. So if you have Windows XP or newer, then you're going to see a DHCP version 6 if it's fully patched. And the configuration method is stateless or stateful. Stateful keeps a record of your connections, whereas stateless does not. And that stateful makes it easy to know whether or not your data was sent properly. DHCP version 6 is just like version 4. Its main function is to provide clients with secondary network configuration information. Neighbor discovery protocol used by IP6 for router discovery. Well, in version 4, there was several different ways a router would discover other neighbor routers, and they were these various different discovery protocols. Well, version 6 has that built into it, which gives it a little bit of a leg up, so it can automatically discover all the different neighbors around it. NATSH, this is a command you'll be using a lot in the labs, and you'll also see those in the quizzes as well. NATSH can be used to manually configure Windows Server 2008 with a static IP address. So you can use that to assign a static IP address instead of using the GUI to do it. And you can also use it to repair a TCP/IP protocol as well, which I've used many times in a network server situation when sometimes TCP/IP gets damaged. Dual layer IP stack. TCP/IP stack in Windows Server 2008 uses a dual layer architecture. You'll read more about that in your book. 6/4 tunnels that can be created, router to router, host to router, and router to host, host to host. So there's different ways you can create these tunnels in order to communicate from version 6 hosts to version 4 hosts. You'll see that many routers and switches already have this capability built into them, and now the server does as well. So you'll need to learn your OSI model. Those are the 7 layers of the entire IP, or entire communication, I should say. It's not necessarily just IP. It's all different types of communication protocols. And if in this particular one, we're showing IP version 4 and IP version 6, which is running at the network layer of the OSI model. Above that is the transport layer, or in this particular case, TCP. This is where the TCP ports are located. They're located right over the IP. And then beneath that is the data link layer 2, which is where the switches operate. You will be disabling IP version 6 in a later lab, and so you can disable IP version 6 using the network connections window or by editing the registry. So you can either go in and uncheck IP version 6 just right from your network connections, or you can go in and into the registry and disable it for all the network interface cards. Sometimes if version 6 does cause problems with certain programs, and you'll need to disable it in order to rectify that. So other times, if you don't have version 6, then you'll also have problems. So it just varies based on what programs, applications, those kinds of things that you install on your server. You can troubleshoot TCP/IP with one of the commands here is ipconfig. ipconfig shows what type of information you have for your network addressing. So I'll just go ahead and type ipconfig, and you can do that from any command prompt. And it tells me my IP address is 192.168, so I know that's an internal address. .15.2. Here's my subnet mask, separating my network from my host, and my default gateway. This is my router to get out to the internet. At the same time, I also see my version 6 address, which was automatically assigned since I don't have a version 6 DHCP server. And my tunnel adapter between that allows me to tunnel back and forth between the version 4 and version 6. So if I wanted to, I could do ipconfig/all, and it'll give me information on all my network adapters. So you'll definitely see a lot more information. It'll also tell me the IP address of my DHCP server, my DNS servers, all kinds of information that you don't see if you don't do the /all. The ping utility tells me whether or not another device is responsive. So I can tell if that device is up or my device is up just by using the ping. So I'll go ahead and type ping, and I'll put in my router address. If it responds, then I know that I can communicate with it. This is a great way to tell if the devices you're connected to are working properly. By default, it sends a 32-byte packet 4 times before exiting. So you can see there's the 4 packets. And byte size is 32. If you wanted to change that size, you could do a -L and any size package you want. And you can see that it responds. Let's see if I go with a really big one like 2048. Also responds. If you don't see a response above 1400, it could mean that your packet size is not enabled for the larger or jumbo frame size. Path ping, used to map hops a packet must take to reach a target. So if I did a path ping to a public address that I know where it is, then it's going to go a little bit at a time until it gets to the destination. So I can see the path that it takes, and these are the different resolved names that it shows as well. All right, trace route is basically the same thing as path ping. It's very, very similar. So if I do a trace route, I'll do a -D so it doesn't resolve all those names because it takes a lot longer that way. And I'll go to that same address I did earlier. You can see it shows the 3 different packets that it sends to it, how long it takes, how many milliseconds, and the path. So it's very similar to path ping. It's a little bit slower because it sends these 3 packets instead of the 1. But there's also additional switches you can use with traceroute as well. Netstat tells you what kind of ports are open on your own computer or another computer. And usually you do the pipe more, otherwise it tends to be a lot of information. And so you can see it goes one page at a time. So these are all the different ports that are open on my computer, and if I've established a communication with these other devices. Effective troubleshooting requires a logical and systematic approach that rules out possible areas of failure and allows you to narrow the search for the root cause of the failure. So make sure you keep that in mind if you're asked about what effective troubleshooting is on a quiz. So in summary, we talked about the different types of networks, routers, IP version 4, IP version 6, subnetting, private IP versus public, the classful and classless, or stateless and stateful, same kind of thing. And then we've got the deploying IP version 4 and version 6 addresses, manually configure static IP addresses, or using DHCP. So that's it for our Module 2, and look forward to seeing your work, and we'll be going on to Module 3.